Video lecture. I am Dr. A.VELMURUGAN, Assistant Professor, Department of Mechanical Engineering, Government College of Engineering, Chettikari, Dharmaburi. In this video lecture from upcoming semester Thermal Engineering 2, Unit 4, Cogeneration and Waste Heat Recovery System. As we discussed about previously, Module 1, Module 2, Module 3, Module 4. From Module 5, we have to discuss about the waste heat recovery system from useful application. What are all the equipments used for to heat exchanging devices for recuperators and regenerator and ceramic recuperators. About the recuperators. Recuperators is a special purpose counterflow energy recovery heat exchanger positioned within the supply and exhaust air streams of an air handling devices or in the exhaust gas of an industrial process in order to recover the waste heat. Generally they are used to extract the heat from the exhaust and used to preheat the air, as I earlier told about the from the air preheater. So again we have to preheat the air, we get the better combustion for the system. In this way to use the waste energy to heat the air, offsetting some of the fuel and thereby to improve the efficiency of the system as whole. In this recuperator, the heat exchanger takes place between the flue gases and air through metallic or ceramic walls. Duct or tubes carry the air for combustion to be preheated. The other side contains the waste heat stream, a recuperator for the recovering the waste heat from the flue gases as shown in the figure. From this recuperator there is a metallic or ceramic walls are present. From the duct or tubes are carry air from the combustion to preheat the air. We get the better combustion in the furnace with the help of the preheat the air. So it will be reduce the fuel consumption, and also the recuperator are recovering the waste heat from the flue gases as shown in the figure. A simplest configuration of the recuperator is the metallic radiation recuperator, which consists of two concentric length of the metal tubing shown in the figure. From the inner tube the hot exhaust gases, while the external annuals are carries the combustion from the atmosphere to the air inlets from the furnace burner. The hot gases are cooled by the incoming combustion air, which now carries the additional energy into the combustion chamber. This energy with does not have to supply the fuel. Consequently, the less fuel is burnt for the given furnace loading. The saving in the fuel also means a decrease in combustion air, and therefore stack losses are decreased not only by the lowering port. From that inlet air is enter to the duct from that inner pipe of this duct. From that tube plate, these are all the from the figure you can see that figure. There is a we have to preheat the air from that recuperator waste heat recovery unit. From here, that is from the pipe the inlet air will be circulated. From here, from this direction, we have to insert the exhaust gas from that process. Again that furnace from the hot flue gases coming out from the furnace. So if that the hot gas is merged on the pipe, means there will be heat exchanging process going on. We get the inlet air will be preheated. That air is entered to the furnace. We have to reduce the load of the furnace load conditions. From this recuperators, three types of recuperators are available. One is a vertical and flat panel. If using this type of recuperator, means we get the efficiencies 15 to 70%. After that, from the horizontal and flat plane recuperator, means we get the efficiency 70 to 80%. From that cellular type, because of cellular type is the honeycomb structure, we this if using this type of recuperator, means we get the 85 to 99%. From here the recuperator is only essentially used for that to preheat the air. If you preheat the air, means we get the better combustion to from the furnace. Next type of recuperator is radiative recuperator. From the radiation recuperator get the name from the fact the substantial portion of the heat transfer from the hot gases to the surface of the inner tube takes place radiative heat transfer. Here the cold air is annuals, however the almost transparent and infrared radiation, so that only convection is heat transfer takes place from the incoming air. As shown in the diagram, from here the hot gases enter to the from the metallic radiation recuperator. From here it will goes to the delivery section. We have to preheat the air continuously from here from the hot from it is also one of the fire tube fire tube boiler only. From the hot gases enter to the tube. From the circulator, from the circular region, there will be the air is circulated from that recuperator. So there will be heat exchanges going on that hot air. So hot air means there will be preheat the air. That preheat air is used for the useful application from the furnace and also to reduce the load. Next heater is radiative recuperator. This type of second common configuration of recuperator is called tube type convective recuperator. As seen in the figure, the hot gases are carried out through a manner of parallel small diameter. So that is a similar for the condenser only, carried out through a manner of parallel small diameter tubes. While coming the incoming air to be heated enter the shell surrounding the tubes and passes over the hot tubes one or more times the directional normal to their axis. If the tubes are fabled to allow the gases passes over the twice, the heat exchanger is termed as a two-pass recuperator. If the two fables are used, the three-pass recuperators are accepted. From this figure, we can clearly see about that recuperator. Here, the hot waste gases enter to this pipeline. So, from here, there is a fable will be presented. If that cold fuel is circulated from that pipeline, means automatically the heat exchange will be happen. From that cold air is preheated. After that, the hot air is goes to the furnace for useful applications. So it is a very good efficiency because of the air will be circulated with the help of the fables means so it is completely merged on the tubes. We get the better efficiency, this type of effectiveness, and also we get better higher effectiveness from this radiation recuperator compared to other recuperators. Next slide, we have discussed about the radiation and convective hybrid recuperators. So this type of recuperators are for maximum effectiveness of the heat transfer, and a combination of radiation and convective designs are used. With this high temperature radiation recuperator being first followed to the convection type, these are more expensive than simple metallic radiation recuperator but are less bulky. A convective radio hybrid recuperator is shown in the figure. From this figure we can discuss about the convective radiative recuperator. From here the cold air is entered to the bottom of the recuperator. It will be go merged on the pipeline. From here, from this pipe, from this area, from this section, that is a convective section. From this convective section we have to hot air is entered to this convective section to increase that preheating the air from the cold air. That the air is goes to the used for useful application, and also it is easily circulated. Again that air is used for the radiation section. So better this convective radiative heat exchange is a very good effectiveness, and also we get better efficiency. It is a very good heat exchanger. The expenditure cost is very high compared to other recuperators. Next slide, we have discussed about the ceramic recuperators. This type of recuperators are used for the limitation for heat recovery of metal recuperator is the reduced life, and also liners and inlet temperature exceeding for 1100 degrees Celsius. In order to overcome this temperature limitation of the metal recuperators, ceramic tube recuperators have been developed whose materials are allow operation on the gas side of 1550 degrees Celsius and then preheat the air from the 815 degrees Celsius and are more or less practical basis. Previously we have discussed about the recuperators for that metal recuperators. Because of if you operating this metal regulator from around 1100 degrees Celsius means the liner and inlet materials also there it will be demolished, and the life of the equipments are very less. So that condition we have to implement it for that ceramic recuperator. If you using this ceramic recuperator means the operating temperature is 1550 degrees Celsius, and also to preheat the air from that 815 degrees Celsius, and it is very useful, and also the life of the recuperators are increasing. The early ceramic recuperators are built for tile and joined with the furnace cement. Because of if using the thermal cycling, because of if you coating for the ceramic means the life of the equipments also increasing, and the ceramic is withstand for that one of the refractories are present on the joints and rapid deterioration of the tubes. because of using the refractories means they have maintaining the high temperature to operating the high temperatures. Later development to introduce the various kinds of short silicon carbide tubes are which can be joined for the flexible scales located on the irrigators. Earlier design had experienced leakages rates from 8 to 16%, but in the new designs in the last 2 years to preheat the temperature high 700 degrees Celsius, which in much lower leakage rates. From this figure, we have discussed, we can see about the ceramic recuperators. This type of recuperator can be used to increase the efficiency of the gas turbines for power generation, provided the exhaust gas in the hotter than the compressor outlet temperature. The exhaust heat from the turbine is used to preheat the air from the compressor before further heating the combustor, reducing the fuel input required. The larger the temperature difference between the turbine out and the compressor out, the greater benefit for the recuperator. Therefore, the micro turbines less than 1 megawatt, which is typically have low pressure ratio, have most gained from the use of the recuperators. So generally from the gas turbine, how to work the gas turbine means the low pressure air is entered to the compressor. From that after the compressor process, the high pressure air is delivered from this condition. From that compressor condition, that is from the combustion chamber, we have to preheat the air with the help of that combustor. If from the combustor process, we have to preheat the air. From that condition, we have to using this type of ceramic recuperators to preheat the air. After that we get better efficiency and also better combustion process will be happen on the combustion chamber. From this operating, the major practical challenge for the recuperator is micro turbine application is coping with the exhaust gas temperature which can exceed the 750 degrees Celsius. Our ultimate aim from the recuperators are used for that heat exchanger. We have to preheat the air before we have. If we have cold air is entered to the combustion chamber, means we need not get better efficiency and also better combustion. So if we have preheating the air, means we get the better combustion. So that purpose we have to using for this type of recuperators are used for the various application. So what we have to even with the help of the flue gases, we have to decrease the load of the furnace, and also we get the better combustion from the combustion chamber. That purpose we have to using this type of recuperators are used for useful applications. Next slide. Thank you.